All right, so this video is going to look at one solution, no solution, or infinite solutions. This goes with lesson 2.3 in our assignments. When it comes to identifying if something has one solution, no solution, or infinite solutions, there's a couple different ways we can go about it. At least in this situation, if I have 2x plus 3 equals 2x plus 7, to identify how many solutions this has, I'm first going to look at the rates. So the rates are going to be those numbers, the coefficients next to x's. So looking at these two, they have the same rate. Visually, what this means is that if I were to graph these, right now they're both going to have the same slope of that 2 over 1. So they have the same rate, but they start at different locations. So if I go back to that graph idea, one of them started at positive 3, and the other started at 7. Both of them have the same slope, and they are never going to cross. This means that they are going to have no solution. So for no solution, they need to have the same rate, but different start values. So just by looking at the format of the equation, this is one way we can tell if something has no solution. The other way we can tell if it has no solutions is by solving. So if I were to try to solve this equation, first I want to try to get my x's on one side of the equation, everything else on the other. I'm going to start by subtracting 3 from both sides. So I have 2x equals 2x plus 4. Then I'm going to subtract 2x from both sides. And I'm going to get 2x minus 2x is 0 equals 4. Now, this is not a true statement. Because it is not a true statement, that's what leads us to have no solution. All right, let's take a look at this one. We've got 2 times x plus 4 equals 3x plus 11. Now, in a situation like this, one of the first few things is it's hard to compare the rates because we have that distribution. We have the parentheses. So let's go ahead and distribute the 2 so that we can then compare the rates easier. So 2 times x is going to get me 2x. 2 times 4 is going to get me 8. And this still equals 3x plus 11. Now we can compare the rates. So looking at the rate, I've got 2x and 3x. Already they have different rates. This means that visually, if we were to look at their graph, one of these is going to be a little faster, the other is going to be maybe a little slower. Already with different rates, this is automatically going to have one solution. Whether or not they have the same start value or not does not matter. As long as they have different rates, they are going to intersect or have one solution. So then, if we were to continue and actually solve for x, I have more positive x's on the right side, so I'm going to move all my x's to the right. So I'm going to start by subtracting 2x. I'm going to have 8 equals x plus 11. I'm then going to subtract 11. And I'm going to end up with negative 3 equals x. So already we have different rates, one solution. When we solve, we are going to get a legitimate answer. Negative 3 equals x makes sense as a solution. That 0 equals 4 did not make sense as a solution. All right. What about 2x plus 3 equals 2x plus 3? Now, same thing, we're going to just look at the format of this. If I were to look at the rates, so far they have the same rate. That's a little similar to our no solution. But then let's look at the start values. So the one on the left starts at positive 3, and the one on the right also starts at positive 3. So in this case, they have the same start value too. This means that they are going to have infinite solutions. You'll also notice that these are the exact same problem. So same rate, same start, or another way of thinking of it is they are equivalent expressions. If we were to solve for this one, I can start by subtracting 2x, and I would end up with 3 equals 3. This is true, and just because they equal each other, that's another way we can tell that they have infinite solutions. The simplest way we can identify as we're going, especially if we have x's on both sides of the equation, is by looking at those rates and start values. So at least just comparing then, this isn't one for you to try, we're going to skip that for now. So at least in general, if you start by compare the rates, so looking at the rates, if they are the same, we have some different options. If they're same, we then need to look at the start value. So from there, if the start value is also the same, there is infinite solutions. If the start values are different though, there are no solutions. And again, when we solve, these may look at like something like we had that 3 equals 3 or 0 equals 4. If we go back to the rates though, if they have different rates, that is automatically going to say that there is one solution. The biggest thing that throws most people off for this one solution is the problem, or any problem that is like 5x equals 3x. Already, if I were to look at these, their rates, one is 5, the other is 3. This means that they are going to have one solution. So if I were to solve for it, I'm going to subtract 3x from both sides. 5x minus 3x gives me 2x. 3x minus 3x gets me 0. And when I actually then divide by 2, x is going to equal 0. I have a value for x. X is 0. That is the solution to this problem. So hopefully that helps as a rundown, at least just looking at the base. You can utilize this flowchart. Otherwise, you can solve and look for those ideas. This one with that one solution, you're going to have an x equals, in this case we had 3 or 0. I'm just going to put 3. You'll have something where x equals an actual value. Hopefully this helps you out as you look at things.